Shall I, everyone? Okay, now write the next heading, that is what? Spring force. Okay. So today we need to complete this topic, that is what? Spring force, and it is also a very easy topic too. Okay. So spring force, very easy topic and very important too. Okay. So spring force, obviously the topic itself is telling you what we are going to learn, what about spring. Okay. Spring is nothing but a coiling like structure. Spring is nothing but a coiling like structure like this. This is nothing but what? A spring. These two ends are called as what? Free ends of the spring. Every spring will be having two free ends. Okay. If there is nothing is connected. Now we can fix this spring to one end and we can connect over here one mass. Okay. The spring can be placed like this also. Okay. The spring over there, we can connect over there like this. We can connect with one angle. Whatever we are going to do, we will do that. Okay. Now, let us jump to our properties of the spring. What kind of spring we are learning in our syllabus. Okay. So, these two ends are the free ends of a spring. Consider, I brought a spring whose length is what? 2 meter. What is the length of the spring? 2 meter is the length of the spring. Okay. And neither, what is the general property of a spring? We can compress this spring and we can expand this spring. Yes or no? So at this point, when I brought or when I purchased the spring, I am not applying any kind of force on the spring. Okay. Neither I am trying to compress that, neither I am trying to expand that. I am keeping the original broad spring as it is. That is what? 2 meter. The real length. What is the real length of the spring from one end to another end? 2 meter. That is what? Original length of the spring. Are yes or no? This original length of the spring itself now is called as what? Natural length. So at natural length, we need to understand if no force is acting. If no force is acting on the spring, that means force acting on the spring is what? 0. No force is acting. Okay. If no force is acting on a spring, then we are going to call that particular length as what? Natural length. Okay. Second thing, what we are going to learn is what? This spring must and should be massless. For our syllabus, we are going to learn what? Massless string. Now, spring. Massless spring. And we already learned what? Massless string. Are yes or no? What is happening in massless string? The force along the string, if string is what? Massless, then it will be always same. Yes or no? Similarly, over here also we are going to learn the same thing. Okay. Now, spring is what? Massless. Then the spring should be ideal in nature. And the next property is what? Ideal spring. When we are going to call a spring as ideal, okay, if the coiling, what you are seeing the coiling now, if the coiling is uniform per unit length, for example, over here, for example, how much? 2 meter we have considered. If I say 100 turns or 100 coiling is being done per meter, that means in the next 1 meter also the coiling should be 100. Or yes or no? 100 turns should be there. Got my point? So we are not going to learn a spring which will be having different coiling. For example, 1 meter you will be having 100 turns and the another end or the another half is having only a 50 or 200. Okay. So the coiling should be uniform. If the coiling is uniform, then we are going to call that spring as what? Ideal spring. I got my point. So right over here, uniform coiling. Okay. So what are the properties, basic properties of this spring? What we are going to learn? First thing, it should be massless. Second thing, it should be what? Ideal. Okay. And the third thing, if there is no force acting on a spring and the real length or the original length itself is called as what? Natural length. Okay. Then the next point. Then what? The next point, what we are going to learn, every spring, for example, consider like this. Over here is one spring and over here is also one spring and one more spring. Okay. Some springs are very thin, some springs are very thick. Someone will be having a smaller turn, someone will be having moderate, or someone will be having n number of turns. Okay. Every spring is independent or having individual properties. Why? Because it will be having some different turns, different thickness. For example, what I am trying to say, we are having a spring in our pen. Yes, same thing, we are having a spring in our car for shock absorbers. Are yes or no? The coiling is same. They are turned like this. Yes or no? Spiral in nature. But the thickness is different over there in car, and the thickness in our pen will be having a different one. Second thing, over here the number of turns are small. Maximum to maximum it will be having 10 or 15 turns. Okay. Similarly, in the pen we are having a spring again, and that one will be having 20-30 turns. Are yes or no? But which one is easy to compress or expand? The spring which is being used in what? In our pen. Yes or no? Same thing. What we are going to deal with, what? Stiffness. Okay, the word stiffness. Now every spring is having its own stiffness. Okay, that means it will be having an individual constant that is represented by a letter K. K is nothing but spring constant. K is what? Spring constant. Spring constant of this spring will be different. Spring constant of this one will be different. Spring constant of this one will be different. For example, let's say the K of this spring is 200 Newton per meter. Okay. How we are getting this in a unit, we are going to learn now. Okay. Similarly, consider this one is having a unit of 400 Newton per meter. Similarly, this one is having a value 100 Newton per meter. Okay. The K will tell you the stiffness of the spring. As the value of K is increasing, okay, stiffness is increasing. That means, for example, if there is a spring, consider over here there is a spring which is been coiled on a rod or whatever it may be. So no need to represent that. Isko nikal do. Consider here is a spring. Okay, here is a spring, and this spring is having a length of 1 meter. Okay. For example, if K is 100, and I want to compress this spring to a distance of 0.5 meter. 0.5 meter, I need some force. Okay, what kind of value, what will be the magnitude, we will discuss later. But for understanding purpose, let's say I am applying a force of 200 Newton. Okay, 200 Newton of force is being applied in this direction, and over here the spring is considered fixed, and I want to press how much or compress how much? 0.5 meter. Okay, if I require 200 Newton of force, with the same value of 200 Newton of force, can I compress this spring? No. Can I compress this spring? No. For example, let us say if this spring, the first spring is being compressed with a unit of how much? 0.5 meter displacement with 200 Newton of force, this spring will take 0.25 meter only. Okay, stiffness is increased, same amount of force, displacement will be less. Okay, we can compress less. This one is having a highest amount, that is what? 400 Newton per meter. With same amount, hardly I can maybe compress this spring to a 0.1 meter only. I got my point. So K, that is what? Spring constant, is telling you about the stiffness of the spring. I got my point. How hard or how soft the value is. I got my point. As the value of K increases, stiffness increases. Okay, so what are the basic properties we have learned now? The spring should be what? Massless. Then the spring must and should be what? Ideal in nature. If no force is acting on a spring, and if we are dealing with what? The original length, and that original length is called as what? Natural length. Every spring will be having its own constant. Okay, K is not a universal constant. Okay, remember that. Every spring is having what? Its own K, that is spring constant, and K tells you what? The stiffness of the spring. Okay, as the value of K increases, stiffness increases. That means you need to apply more and more force for what? Displacement. I got my point. Till here, write these 4 properties. Now we are going to learn the next few properties. Okay. Okay, shall I? Everyone written now? Okay, now already how many points we have completed? 3 points. One is what? Massless. Second is what? Ideal. Third is what? Natural length. That is nothing but original length. At original length, force acting on the spring is how much? 0. Okay. Now consider over here is one spring like this. Okay, and this one is being fixed over here. One end of the spring is fixed, and consider another end of the spring is connected with some mass like this. Okay, it is having its mass. Now, if I keep as it is, no force is acting on that spring on the block, force acting on the whole system is 0. That means, let's say its length is from here to here is 2 meter again. Okay, that means, can I say this 2 meter is nothing but natural length? One more thing, let me tell you, sometimes they will provide you the value of natural length, sometimes they won't tell you any kind of values. Okay, why? Let us try to understand over here now. For example, if I apply the force in this direction, I applied some external force on this, obviously this block will be going in that direction. Yes or no? Let's say the value of K is K. Whatever the value of, every spring is having its own stiffness. Yes or no? And that stiffness is defined by what? Spring constant. I got my point? Okay, now I am applying the force in this direction. After some time, let's say this block reached here, and let's say the distance from here to here is what? 1 meter. How much? 1 meter. Now what is the new length of the spring? Total 3 meter. Yes or no? If this is the new length of the spring is from here to here is 3 meter, the next property of a spring is what? Spring always exerts the force. Spring always exerts the force. Who is exerting this time force? Spring. Because of the external force. Okay. Spring always exerts the force in the direction so that it attains its natural length. Spring attains its what? Natural length. So for attaining the natural length, where do you think it will apply the force? For example, what is the natural length now? 2 meter. What is the new length of the spring is how much? 3 meter. Yes or no? So displacement is happening in this direction. Yes or no? And spring will apply the force in this direction. So this is the direction of what? Spring force. I got my point. So spring try to apply the force in this direction so that it attains its what? Natural length. I got my point. And it is being given by Hooke's law. Okay. And Hooke's law says that F is directly proportional to X. F is directly proportional to what? X. This is nothing but spring force. Yes or no? Spring will apply the amount of force which should be directly proportional to what? The amount of displacement. If you displace this object more and more, spring will apply the more and more force in the opposite direction. That to be what? In opposite direction. If I remove the proportionality sign, I will be writing F is nothing but equals to minus times of Kx. This is nothing but the equation what we are going to learn. Okay. Spring force is directly equal to or directly proportional to displacement, or spring force is nothing but equal to minus times of Kx. Okay. Generally, we do not represent it with what? Negative sign. Why? Because we need magnitude. Now come back over here. If the same spring, can I say it can be displaced or compressed in this direction like this? Same spring can be compressed like this. Yes or no? What is the natural length? Here is the natural length. That means natural length is what? 2 meter. I compress this to a displacement of 1 meter. Now where do you think spring will apply the force? In this direction. So displacement is happening in this direction. Spring force will be applied in this direction. Now if I want to say something, then can I say that spring will always apply the force opposite to the direction of displacement? Is that statement true? Yes. Or can I also say that spring will always apply the force or exert the force so that it attains the natural length? बोल सकता हूँ क्या? देखो, हाँ, अरे देखो बेटा, from here to here what is the length? 2 meter. Spring will apply force in which direction? In this direction. Is it attaining its natural length? Yes or no? So can I say the next statement as spring always exert the force? Spring will always exert the force so that it attains its natural length. First option. Second option, we can also say that spring will always apply the force opposite to the direction of displacement. Yes or no? If we are trying to expand this, the spring want to compress itself. Yes or no? Not, we should not say compress itself. It tries to attain its natural length. I got my point. So always remember, and we can also write over here the value of or unit of K also. So from here, can I say K is nothing but F upon X, and F is measured in terms of Newton and X is measured in terms of meter. Are yes or no? From here, we can also write the dimensional formula also. Are yes or no? Dimensional formula of Newton, that means force. Dimensional formula of M is nothing but L. Substitute, and 1L and 1L get cancelled out. Are yes or no? And we can also state what? Dimension formula of K. इसका dimension formula लिख दो and explain this. Whenever you are applying the amount of force, spring will always exert the force in the opposite direction of what displacement, or it always tries to attain its natural length. Okay, write these 2 points. Okay, and complete that also. Okay, shall I? One more property of this spring, let us try to understand in this way. Consider there is a spring and this is fixed over here, and this one is at its natural length, and I am applying some force on this over here. This mass is M. Okay, and the spring constant is given, let's say K value. K is nothing but 100 Newton per meter. Okay, mass of the block, take 1 kg, 2 kg, 10 kg, whatever it may be. Initially, no force is acting. That means this is the natural length. Okay, whatever the value, 2 meter, 5 meter, 10 meter, or 0.5 meter, whatever the length of the spring is. Okay, I applied some amount of force. And I want to expand this. Definitely, F external should be acting in this direction. Obviously, spring will try to apply the force in this direction. Are yes or no? After some time, let's say this block reached here, over from here to here, the displacement is again 1 meter. How much is the displacement? 1 meter from its natural length. All the distances are measured from what? Natural length. Yes or no? Okay, now spring will apply the force in this direction. F external is applied in this direction. Okay, what is the spring force value? FSP is nothing but minus times of Kx. Are yes or no? How much is the displacement happened? 1 meter. What is the value of K? 100. So spring force is nothing but minus times of, can I say, 100 Newton. No need to represent over here minus. We know that spring will always apply the force in the opposite direction of the displacement. Okay, what is the force? How much? 100 Newton. Are yes or no? So spring is applying 100 Newton of force on the block opposite to the direction of, what can I say, displacement, or opposite to the direction of external force in this one, or can I also say that it will try to regain its original length, that is natural length. Can I say that? Okay. Now what is the property here is, if I measure at this point, if I measure at this point, or if I measure at this point, wherever I measure the force on along the string, okay, whatever and wherever I measure the force along the string, that remains 100 Newton only. I got my point. So can I say that spring force, why? First thing, this is one is a massless spring na. So similarly to what? String. Whenever the string is massless, force along, that means the tension along the string is same. Same thing is applicable here also. Whenever we are considering massless spring, force along the spring remains same. So now, same thing, one more time. Consider same spring is now displayed to a distance of 2 meter. Displays how much? 2 meter. K is again 100. Now tell me, K is equals to 100 over here. How much is the displacement from its natural length? That is what? 2 meter. 2 meter. Now tell me, same spring, same situation, but this time we are going to display that by 2 meter. Will spring force remains 100 or it will turn to 200? 200. So now this time the spring force becomes what? 200 Newton. Are yes or no? Just now we are saying that whenever we are applying some force on a spring or on a block and it is being expanded or it is being compressed, same thing. If I compress this to a 1 meter distance, again I will be getting what? 100 Newton only. If I expand the spring, again I will be getting what? 100 meters. So for compression or for expansion, if for a same displacement I require what? Same amount of force. Okay, I will get the same amount of spring force also. I got my point. Okay, now one thing we need to understand: same spring, same mass, same K value. Okay, when I display to a distance of 1 meter, I am getting what? 100 Newton. But when I am applying the same over here, displacement is what? Twice of that original initial one. I am getting 200 Newton of force. And just now we said that spring force along the spring, that means spring force along the spring remains what? Same or constant. Over here, if displacement changes, if what? Displacement changes, spring force changes. If I say along the force is 100 meter, that means I am calculating with respect to what? Displacement from its natural length. I got my point. Samajh aayi baat? Okay. So you will be getting two different statements. Spring force along the spring is same or always constant. Yes, that is true for a particular displacement. Spring force is a variable force. Yes, that is also true. Variable na. Over there we got what? 100. Over here we got what? 200. I got my point. Spring force is a variable force. That is true. Yes. Again, it depends on what? Displacement. If displacement is changing, spring force changes. True. Okay. But wherever I keep that one, if I say over here, I stopped at 2 meter. I stopped at 2 meter. Spring force along this spring from here to here will be 200 Newton only. If I measure over here, if I measure over here, if I measure over here, wherever I measure along the what? Spring, I will be getting 200. Yes, that is true. If I measure over here, I will be getting 100 meter. Yes, that is true. So spring force along the spring is constant. That is true. Spring force is a variable force. That statement is also true. But it depends on what? Amount of displacement. I got my point. One more time, those who haven't understood, still they are, consider here is the spring. Okay. At this point, here is the natural length. And I expanded this to a distance of 1 meter. Okay. K value, if I say K is equals to 100 Newton per meter, what is the spring force now? 100 Newton. Are yes or no? Spring will apply 100 Newton of force. In which direction? In this direction. I got my point. Similarly, same object is brought here to a distance of what? 2 meter. That means from here to here. Now the new distance is what? 2 meter. This distance is what? 1 meter. Okay. Now the spring will apply how much force? 200 Newton of force. This 100 Newton of force at this point or at this position. I got my point. This 200 Newton of force when the object is being brought here. So as the displacement changes, spring force changes. That is the reason I am telling you spring force is a variable force. And I am saying that spring force along the spring remains constant or same because whenever you keep at 1 meter, the spring force remains 100 only wherever you measure. Ab aaya samajh mein? Okay, thank you. Explain yourself. Okay, shall I example number 1? Okay, example number 1, still we are going to learn one more property, that is what? Mean position. Okay, now consider, everyone just listen to me, consider here is a spring and this spring is being kept like this and consider this mass is 10 kg, 1 kg, whatever you want to take. Consider this K value is nothing but 10 Newton per meter. Okay, 10 Newton per meter. Initially any force is acting. If I say from here to here, it's natural length. At natural length, we already know that force acting on the spring is what? 0. If no force is acting on a spring, that particular position is also called as what? Mean position. Okay, F net should be 0. Net force at any point, if it is 0, then that particular position is called as what? Mean position. Okay, that particular position, whenever F net becomes what? 0. That is what? Mean position. Over here, no force is acting. That is the reason. Can I say that? In this situation, natural length and the mean position both will be at same point. Can I say that? Yes or no? Okay. Now, if I apply some external force, let us calculate the acceleration of this one. if I expand this in this direction and I brought this spring over here, and if I say the displacement is let's say 1 meter from the mean position. What is the displacement? 1 meter from the mean position. Then I release this object. If I release this, where do you think it will be going? In this direction or in that direction? Obviously in that direction. So this block will be going in this direction, and the question is find out the acceleration of the block. Find out the acceleration of what? Block. Now tell me, can I also say that at this position also, that is what? Mean position? No, no. Mean position is here. Why? Because no force is acting. At no force is acting means it is nothing but natural length in this case. I got my point. Whenever we keep the object or the system at horizontal, natural length and the mean position will come at the same point. I got my point. And when I display it in this direction, that means from here to here I need to apply the force. Yes or no? So F external is acting in this direction, and can I say that spring force is acting in this direction? Yes or no? Okay, if displacement is in this direction, if I say I release that, then obviously object will be going in this direction and acceleration will be in this direction. Who will be greater? FSP? Yes or no? When it is being released, F external become what? 0. So can I say that F external or FSP, this is the direction of displacement. Who is bigger in this direction? FSP minus of F external, which is equals to what? MA. Can I write like this? When it is being released, this becomes what? 0. Yes or no? Obviously it becomes what? 0. No external force is acting then after release. Okay, then can I say FXP is nothing but MA, and we have said M is what? 10. Yes or no? Acceleration we don't know, and Fxp is nothing but this is equal to Fxp is equals to what? Kx. Okay, no need to substitute the sign because we are calculating definitely the magnitude, and you know the direction. Obviously it is going in the direction. Yes or no? So from here, can I say that Kx is nothing but equal to Ma? Yes or no? Or I want to calculate the acceleration, then Kx is nothing but upon Kx upon M. Or acceleration K value is what? How much? We have said 10. X is what? 1. Mass is what? 10. This 0 and this 0 cancel. Acceleration is equals to 1 meter per square second. Yes or no? Ayana. So always remember, when it is being released, F external becomes what? 0. Okay. And over here, this is the situation what is happening in horizontal cases. Okay. And in horizontal cases, natural length and the mean position both will be at same point. Okay, and if you apply the force another than the natural length, or in that direction or in this direction, obviously the mean position and the natural length both changes, and you know where the spring will apply the force. Yes or no? Spring will always apply the force opposite to the displacement. I got my point. And when it is being released, obviously that particular length or the force at that point becomes what? 0. This is the equation. I got my point. Or in horizontal cases, if this is the situation, or they can also ask you from mean position or from natural length, we brought an object to a distance of 1 meter. If from here again we took our object to a distance from here, certain distance, let's say initially it is 1 meter, again 1 meter is brought over here. What is the distance from x value from its natural length? Now it becomes what? 2. All you need to substitute, x value is equals to 2. I got my point. So always remember, x value is substituted from where? Natural length. I got my point? Right on. Okay, shall I? Example number 2. Now we will keep the object in vertical direction. Okay, we will place the whole system in vertical form. Consider Over here, one spring is there. This is the spring. No mass, nothing is being connected. Can I say over here, this is nothing but the natural length? Can I say that? Okay. That means this is the position of what? Natural length. Okay. Now, what I did is, I connected one mass. If I connect the mass, will it stay here? Kyo? mg will be acting na beta. If I say this is 10 kg. Obviously 10 kg means 100 Newton is acting in this direction. Let's say this K is equals to again 100 Newton per meter. Okay. Obviously this object won't stay here. This object will reach to this point. Now this object will be coming here. Where is mg acting? Initially mg is acting in the downward direction. Over here is also mg is acting in the direction. Yes or no, mg doesn't change its direction. But what happens is spring get increased na its length. ऐसे increase हो जाएगा. Yes or no, you will be finding some expansion in the spring because of mg. Now at this point over here, can I say this is the direction of kx? Okay. After some time, it will oscillate, but it will stay there only now. We are not going to learn SHM now. Okay. So, when we brought a 10 kg object, when it is being connected to its natural length, when suddenly I release over here, then this object reaches here. Okay. When this object reaches here, at this point, now this is the mean position. Now this is the mean position. In the earlier example, when we kept over there in the horizontal direction, natural length and mean position both are same. Okay. But when I connected in a vertical direction, natural length is here, but mean position is here. Mean position means what? F-net should be 0. Are yes or no? So F-net should be what? 0. F-net should be 0. How many forces are acting on this one? Two forces. One kx in the upward direction, mg in the downward direction. That means, can I say in this one, kx should be equal to what? Mg, and this is the mean position now. Okay. How much is the displacement happened from its natural length? We can calculate from here. We know k value, we know mass, g is 10, obviously x can be calculated. So they can ask you, find out the mean position of the spring or of this system. I got my point. Then we can say that x is nothing but mg upon k. Or can I write like this? Mg upon k, or x is equals to mass is what? How much? 10, and that is what? 100. This is also 100. That means 1 meter. I got my point. Okay, but things will be changing. Things will be changing. Acceleration at mean position becomes what? 0. Acceleration at mean position becomes 0. Why? Because both the forces acting on the opposite direction both are equal. Are yes or no? That means F-net becomes what? 0. If F-net is 0, acceleration is also 0. Now, I need to apply some external force, either in the upward direction or either in the downward direction. Yes or no? If I apply some upward force, then release, then where do you think the block will be going? सोच के देखो. If I apply some force in this direction, where is the mean position? Mean position is here. Now object will reach here. Object will reach here. If I release from here, it will try to attain its mean position. Now it won't try to attain its natural length. Got my point? Whenever in vertical form, in a vertical system, if I apply the force in the upward direction, then I release, it won't try to attain natural length. It will try to attain its mean position. Definitely the acceleration will be in the downward direction. Okay. Similarly, if I apply the force on this block in the downward direction, definitely the block will be coming in the downward direction. If I release from here, it directly won't reach to the natural length. It will stop at its what? Mean position. I got my point. Let me do one more question here. Consider here is the block. From here there is a spring, and that spring is connected at this point. So this is the mean position now. Yes or no? This is the mean position. Whenever the object is being kept in the vertical form, definitely it will stop at mean position. At mean position, F-net becomes 0 and Kx is equals to what? Mg. This is happening. Okay. And if I apply some external force on this block in the downward direction, and I brought from here to here 1 meter. Okay. Same, how much we have taken? 10 kg. And this is what? 10 kg, and K value is what? 100. K value is 100 Newton per meter. That means, can I say that what is the mean position? This is the equation. We can calculate the mean position. Kx is equals to mg. If from mean position some external force is applied and the object is brought 1 more meter downwards in this direction. Okay, we need some external force to bring the object in the downward direction. If I release this object, definitely it will stop at the mean position. It won't stop at the natural length. Natural length will be somewhere here. Mean position is here. Okay. Now, if I apply if I extend it to a distance of 1 more meter, then what will be our equation? Obviously, acceleration in the upward direction. Are yes or no? When I release this, definitely this one try to go to mean position. Are yes or no? If it is trying to go to mean position, Kx is acting in this direction. Kx is acting in this direction and mg is acting in this direction. But this time, this x will be different. Are yes or no? Why? From here to here 1 meter, from here to here 1 meter. Now this x should be represented with what? X dash. I got my point. So what should I write the equation? Who will be greater? Kx dash will be greater or mg will be greater? Kx dash will be greater. Why? Because acceleration is in the upward direction. So Kx dash minus of mg, which is equals to what? Ma. Are yes or no? X dash is nothing but mean position. From the mean position or natural length? From the natural length. From the natural length, how much it is been expanded? This is the 1 meter and this is also 1 meter. So x dash value should be 2 and k value is 100. So this is 200 minus of mg is how much? 100, which is equals to 10a or 100, that is acceleration is equals to 10 meter per square second. I got my point. Array. So whenever things will be changing when the object is being kept at an angle or vertical, but the things will be changing when it is being kept at what? Horizontal. At horizontal, always remember natural length and the mean position lies at the same point. Okay, no worries about over there. But when it is being tilted or when it is being placed vertically, natural length will be different and the mean position will be different. Okay, sometime they will ask you the question like, from mean position 2 meter is being displayed. That means you need to calculate first where is the mean position from the natural length. This is the equation how we calculate. Okay, and from whatever the value they will provide, again that 1 meter plus of extended total distance over here x dash. I got my point. ऊपर ले जाएंगे तो बेटा एक्सेलरेशन नीचे होगा ना, अभी बताया ना तुमको. इधर देख लो. From here, consider this is the natural length. At this point, this is the natural length. Over here is the mean position. Okay, when it is being released, that means I have to apply some force in the upward direction, F external. From F external, consider I brought till here and then release. That means acceleration will be in the downward direction. Why? Because in a vertical direction, the object want to move at the mean position, not to the natural length. आगे समझ 4 क्वेश्चन करेंगे, समझ में आ जाएगा. ओके, okay, shall I? Example number 3 to whatever the value is. Okay, now let us try to understand when it is being tilted. Okay, consider like this. Here is a system. There is a triangular wedge and the value over here, let's say 37 degree. Okay, and over here, one spring is being connected. One spring is being connected. Okay, at this point, इसको बड़ा बनाएंगे तारा. Here is the object, 10 kg. K value ले लो 30 Newton per meter. Okay, first tell me, this will be the mean position or this one will be the natural length? Think and tell me. Mean position, yes, very good. Now, why we are saying over here is mean position? Because mg is acting in the downward direction. Are yes or no? Over here is nothing but mg cos theta. That is mg cos of 37 degree. Are yes or no? Over here is nothing but mg sine of 37 degree. Can I write like this? If one force is acting in this direction, who will balance that force? Spring force. It is acting in this direction at this point. So can I say that this is the position for mean position? Are yes or no? Natural length will be somewhere here. I got my point. So natural length is now different this is the mean position. Why? Because mg sine 37 and kx both are acting in this direction. So find out the mean position if the question is. All you need to do what? Kx is equals to mg sine of 37 degree. Are yes or no? Substituting the value, x is equals to this value is what? 100 into 3 by 5 upon 30. So this is ones, this is tens, 1 0 1 0, 5 ones are, this is 2. So x is equals to 2 meter. Or x is equals to how much? 2 meter. That means from here, if this is the mean position, natural length, from natural length it is already been extended to a distance of 2 meter. Are I got my point? Okay, very good. Now the same thing, they can frame that. Find out the acceleration if the object is brought 2 meter from here. So same 10 kg. This extension is 2 meter this time. This extension is what? 2 meter. Okay, find out the acceleration. Now if I release from here, who will be greater? That force will be greater, no? Why? Because acceleration is happening definitely in this direction. So acceleration is in this direction. Now if I want to calculate from the natural length, this is at the main position, already 2 meter expanded. Are yes or no? So 2 meter plus of this 2 meter, how much? 4 meter. So can I write kx dash minus of mg of sine of 37 this time? Why? Because who is acting in this direction? mg sine of 37 is acting. So mg sine of 37 will be smaller than kx dash, okay, which is equals to what? ma. I got my point. Okay, substituting the value, k is what? 30 into how much? 2 or 4? 4, very good. So 4 minus of mg, that is what? 100 into 3 by 5, which is equals to 10. A, once this is what? 20, 60, 120. Minus of 60 upon 10, that is nothing but acceleration. So acceleration is equals to 6 meter per square second. Can I write like this? Okay, this is how we do. So always remember what is happening when it is being kept horizontally, when it is being kept vertically, and when it is being tilted. Okay, so where do you find natural length and the mean position at the same point? When it is being kept at horizontally. Okay, if you keep with angle, if you keep at what angle, or if you keep exactly vertical, then natural length and the mean position both are not equal. I got my point. Explain this, we will do some more problems. Okay, shall I now write one small subheading? Method 2, finding acceleration without mean position. Okay, now we know how to find the mean position as well as what? The acceleration if the system is, or the spring is being kept horizontally, if the system is tilted with an angle, or if the system is placed vertical. Yes or no? Now finding the acceleration, and we don't want to find what? The mean position. Let us try to understand this. So based on that, example number 1. Now listen to me. Okay, you know how to do this, but even though, let us try this. Consider here is a spring. And consider over here a block is being connected. Let's say the block mass is 10 kg. Okay, where is the mean position? This one will be the mean position. So consider this is your mean position, and somewhere over here will be the natural length. Are yes or no? Natural length will be somewhere over here, and this one will be the mean position. At mean position, what is our condition? F net becomes 0, na? So at mean position, can I say F net is equals to 0? F net is equals to what? 0. If F net is 0, what is the acceleration? At this point, 0, na? Why? Because Kx and mg will be equal. Kx and mg will be equal. Over here, Kx is acting in the upward direction, mg is acting in the downward direction. That means, can I say Kx and mg are balancing each other? That means both are equal, na? Are yes or no? So from point that is natural length, to the mean position, there is no acceleration. Acceleration can be happen if I take this object over here slightly above the mean position, definitely there will be some acceleration, but it is in the downward direction. Yes or no? But now what we are doing, let's say this object is being taken further away in the downward direction. Let's say object we brought here. Okay. And from the mean position, I said object is being shifted in the downward direction or being dragged in the downward direction by a distance of 2 meters. By a distance of how much? 2 meters. Generally, they don't provide with 2 meters. They hardly provide with 20 centimeters, 30 centimeters, so on. Okay, all you need to convert that in terms of meters, SI unit. Okay, now, at this point, 10 kg will be here. If from here it is being released, from here it is being released, where do this block be going? Obviously in the upward direction. So this block will be going in the upward direction. So acceleration is also in the upward direction. Now tell me, the question is, what distance is creating in reality, or the displacement is creating the acceleration? Can I say this 2 meter? Yes or no? At this point, F net is 0. Obviously, there will be no acceleration at all at mean position. So that means, can I say that over here, that means this 2 meter, because of this 2 meter, the object is being dragged in the downward direction. This one is creating the acceleration. Then can I write like this? If acceleration is in the upward direction, that means that force, that is what Kx is in the upward direction. This is the force which is generated by the spring, which is equals to Ma. Which is equals to what? Ma. Now, this x should be measured from what? Mean position. If I measured this from the mean position, this is the displacement which is creating this acceleration. Okay. So, Kx is equals to Ma. K value, let's say, take 100. K is equals to how much? 100 Newton per meter. Okay. And substituting over here, 100 into, now this time, x should be substituted, that 2 meter, not from the mean position. Okay. If we calculate, we will be getting some different value of the mean position. Yes or no? Substituting over here, I think maybe 1. Whatever it may be. So, over here, x value should be 2, which is equals to mass of the block is 10 into A, or acceleration is equals to, that is what, 200 upon 10. That means 20 meter per square second. Okay. Now, is this our answer correct or not? Let us try to find with our basic method. Okay. What do our basic method says? From year to year, we need to find that. Yes or no? That means Kx is equals to what? Mg. And x is equals to mg is nothing but 100. That is divided by this one. X becomes 1 meter. Yes or no? And similarly, then again substituting in the second equation, that means applying the second law, then I will be getting what? Kx dash minus of mg, which is equals to ma. Can I write like this? Can I? And Kx dash now will be becoming how much? This 1 and this 2. Total 3. Substituting over here, K value is 100 into 3 minus of this 100, which is equals to 10A. Okay. 300 minus of 100. Again 200. 200 divided by 10. Again acceleration becomes how much? 20. That means we can find the acceleration without finding the mean position. Okay. And how we are considering that? At the mean position, we know that F net is 0. If F net is 0, obviously there will be no acceleration. If no acceleration, then who is generating the acceleration? This distance or this displacement. Because of this displacement, the force which is being generated or exerted by the spring will be different. Yes or no? Why? Because spring force is a variable force. I got my point? So we can apply this method. Either the object is being tilted, we can apply over here also. Like this. Over here, this one is block. Over here, if this is your theta, mg sine of theta, if I somewhere displayed over here. So this displacement which is generating what? The acceleration. Okay, if this is the mean position over here. Okay, you can apply that in third question. We can directly get the acceleration also. Pani pila re bhai. Okay, right on. Okay, try this. Try this, okay. Now consider the system is kept like this. And here is one pulley. On this pulley there is a spring, and here is the block. Let's say this is your 5 kgs. K value 100 ले लो, and one more block is been connected here. ले लो 2 kg. Where will be the acceleration? Downward. Yes, this one will be accelerating in the downward direction. At this point, mean position and kx both will be same. Okay, देखते हैं. And consider, shall I apply some force over here? Okay, so let's say in this direction 15 Newton is acting. So one external force is acting on this block, mg is acting on this block. Find out the acceleration. Try करो. Okay, shall I? Yes, this one is also massless, this one is also massless. मैं बोला क्या mass बोल के, क्यों सोचता फिर? Okay, now listen to it. We will be getting two equations. How we will be getting this? Over here, 5 kg is accelerating in the downward direction. Who is acting in the downward direction? Obviously, mg is acting in the downward direction. Okay, kx is acting in the upward direction. Who is greater this time? Mg or kx? Mg will be greater. So for this block, 5 kg block, if I want to write the FBD of this one, then mg will be greater minus of 5 kg, which is equals to ma. Can I write like this? Okay. Or substituting the values, m is what? 50 minus of kx, let's say kx, which is equals to 5a, equation number 1. Similarly, on this force, how many forces are? On this body, how many forces act? First, tell me what is the value of kx here? Kx over here, kx on this string, kx. If this one is massless, then over here is also kx. Over here is also kx. Both tension over here is nothing but kx. Who is acting in this direction? Obviously, this block is going in this direction. That means acceleration is in the direction. T will be greater. That is, T is nothing but kx. So, for 2 kg, I will be writing what? Kx minus of 15, which is equals to 2a. Can I say this is your equation number 2? Can I say that? Adding equation 1 and 2. Khatam kar lo answer. Okay. So, what is our first equation over there? 50 minus of kx is equals to what? 5a. Adding equation 1 and 2, this kx and kx it cancel. Are yes or no? And left out is what? 15 and this minus of that is 35. 35 is equals to what? 7a, or acceleration is equals to 35 upon 7. That is nothing but 5 meter per square second. Okay. They won't provide you this one. Even though we can write the equation over here, that is second equation becomes t is equals to, or kx is equals to 2a. अरे यस और नो? खत्म है. इतना क्या करते रहे? सेकंड इक्वेशन लगाना था. ओके, ट्राई दिस आल्सो. ट्राई वन मोर. और थोड़ा एक कर लो. हियर इज अ सिस्टम. दिस एंगल इज गिवन 37 degrees. Over here is one block, 1 kg. This one is connected like this. Here is the pulley connected. Over here there is a spring. On this spring one block is connected, and 37, that means the over here, okay, this one becomes k is equals to 100 Newton per meter, and consider this as acceleration in the downward direction. Obviously this is 15 kg. Okay, if answer is not coming good, substitute whatever the values you are want to. अगर अच्छा आ रहा है तो कर लो. Okay, come on, find out the acceleration. Again the same question. Be quick. Okay, shall I? आगे सभी का अच्छा है आंसर. Okay, very good. So for 15 kg, if I want to write the FBD of the 15 kg, then acceleration is in the downward direction, mg is acting in the downward direction, kx is acting in the upward direction. Over here is also kx. Are yes or no? Over here, can I say that in this direction kitna hai? Mg sine of 37. In this direction, mg sine of 37 is acting in this direction. Obviously, acceleration of the body will be in that direction. Are yes or no? So for second equation, kx minus of mg sine 37 is equals to ma. And for this one, mg minus of kx is equals to 15a. So I am writing for the 15, that is what? Mg minus of kx is equals to 15a. This is your equation number 1. So for 1 kg equation, kx will be greater. Why? Because acceleration is in the upward direction. So kx minus of mg sine of 37. Sabhi ka ye hai equation 1a. Equation number 2. Are yes or no? Acceleration same होगा बेटा. Why? Because these forces are same ना. This one is kx and this one is kx. a1 a2 क्यों आएगा, नहीं आएगा. Okay, now adding equation 1 and 2 over here, can I say this one and this one get cancelled? Yes. Over here, what is the mass of this one? 15 into 10, that is what, 150, minus of over here is what, 1 kg, that means 10 into sine of 37, that is what, 3/5, which is equals to 16a. Are yes or no? ये कितना हो गया? Once, this is twice, that is 150 minus of 6, that is equals to 16a. कितना कट हो रहेगा? Okay, 144 upon 16, that is equals to a. This is once, this is how much? 9. So acceleration is equals to 9 meter per square second. How many of you got these things? Everything is connected now, interrelated. This one is completely based on what? Second law again. Yes? कोई doubt है? No, no? Okay, right on.